Welcome to 4.6, where we're going to be working with mixed numbers. So we're going to be adding, subtracting, multiplying, and dividing with mixed numbers. So basically that means with fractions. So let's have a look. So the first thing we're going to do is multiply. When you're multiplying mixed numbers, what you're going to do is you're going to turn your mixed numbers into improper fractions. It's simply the easiest way to do it. And so what we'll do is we'll take 2 3/4. So if you remember, we take our whole number, our 2, and we multiply it by the number of parts in a whole, 4, and then we add that to however many pieces we had left over. So 2 times 4 is 8, plus 3 is 11. So 11/4. Because 4 goes into 11 two times with 3 left over. And so it would get us back to where we started. Now we have 3 1/5. So 3 times 5 is 15, plus 1 is 16. So 16/5. So now we have two fractions, 1, 2, and we're multiplying them. So I'll write them next to each other. And when I multiply fractions, remember, I don't have to have a common denominator because I'm multiplying straight across. So it's 11 times 16 over 4 times 5. I see here I can reduce because 4 goes into 4 once and into 16 4 times. So 4 times 11 is 44. Over 1 times 5 is 5. And I can leave it like this, or I can turn it into a mixed number. And since I started with mixed numbers, I probably should, it would be the best practice for me to turn it into a mixed number. So to do that, I simply have to divide. 5 into 44 goes 8 times, 8 whole times, because 8 fives is 40, with 4 left over. So 4/5. So 8 4/5, or 44/5. Now that's multiplying mixed numbers. Dividing mixed numbers is pretty similar. We're going to turn our mixed numbers into improper fractions, and then we're going to divide like they were normal fractions. So let's have a look. 1 3/5. So 1 times 5 is 5, plus 3 is 8. So 8/5, because there's 5/5 in one whole, so 5/5 and 3/5 is 8/5. Okay, and now I have 2 4/5. So 2 times 5 is 10, so there's 10/5 in two wholes, plus 4. 2 times 5 is 10, and 4 is 14/5. So instead of mixed numbers, I'm looking at improper fractions. It's 8/5 divided by, oh, interesting, 14/5. So now that I'm dividing, instead of dividing, I can multiply by the reciprocal. And when I multiply straight across. I have 8 times 5 over 5 times 14. And the reason I didn't do the math is because I see that I have 5s top and bottom. So I want to divide my 5s here. So I really have 8 over 14, because 5 divided by 5 is 1. And so that, and 1 times anything is itself. So when two numbers cancel, assuming there are other numbers there, then a 1 is left in their place, but when you multiply by 1, it doesn't change anything. So unless we need a placeholder. So now we can divide top and bottom by, well, they're both even, so let's start with 2 and see how that goes. 8 divided by 2 is 4, and 14 divided by 2 is 7. So 4/7. And 4/7, that's going to be in lowest terms. Because they have, there are no factors that are common to both 4 and 7. Other than 1. And that won't make it any smaller. So we're all done there. So that's multiplying and dividing. Now, adding and subtracting is a little bit different because we don't have to turn the mixed numbers into improper fractions first, because we could add the whole parts, right? Whole numbers do go together. So what we could do is use the commutative property to rearrange the parts so that we could say that the whole parts go together and the fraction parts go together, and we could deal with them separately. So that's what we're going to do. So if we want to add 3 2/3 plus 4 1/5, then what I'll do first is I'll recognize the mixed number. 3 2/3 is really 3 plus 2/3. And now I can use the commutative property to say, oh, well, that's really 3 plus 4 plus 2/3 plus 1/5. And so now I can add the whole parts and the fraction parts. So 3 plus 4 is 7. So that part's done. Now is where it gets a little trickier. So I can add these. Now the way I like to do it is I usually like to stack it to make room. So I'll say 2/3 and 1/5 I'm adding. What's my common denominator? 3 and 5. What number do they both go into? They both go into 15. So 3 times 5, got to do that top and bottom. So 10/15 is an equivalent fraction to 2/3. 5 times 3 is 15. Do that top and bottom. So 3/15 is an equivalent fraction to 1/5. Now I'm adding, and when I'm adding, as long as I have the same denominator, I can add the numerator. So this is really 10 plus 3 over 15. So 13/15. So this is 7 plus 13/15. And I can add them, or I can write them next to each other in mixed number notation. So when I write a whole number next to a fraction, I know that it means add. I know it means that they are being added together, combined. Now let's go ahead and subtract. So if we want to subtract 12 7/10 minus 8 3/5, we can subtract the whole parts, and we can subtract the fraction parts separately. So let's go ahead and do that. So let's stack them. And then let's come up with a common denominator, because 10 and 5 aren't the same, so they both have to go into something. They both go into 10, because 10 times 1 is 10, so that one won't change. And 5 times 2, so I have to double the top as well, so 6/10 is the same as 3/5. So now it's 12, so now it's really 12 7/10 minus 8 6/10. And so since I don't have to borrow, since 7/10 minus 6/10 can be done, that's 1/10, and I don't have to borrow, I can do 12 minus 8 is 4. So 4 1/10. right, now let's subtract again. This time it's going to be a little more difficult. 10 minus 5 and 2/7. So when I go to stack it, I have 10 minus 5 and 2/7. So the problem is, until I figure out how to take the 2/7 away, I can't take the 5 away. So what I can do is I can borrow, right? Because 10 is the same thing as 9 plus 1. And then instead of 1, I could write 9 plus, well, instead of 1, I could write 3 over 3 or 2 over 2. But in this case, because it's in sevenths, I'll write 7 over 7. Now, 7 over 7 is 1, and 9 plus 1 is 10. So I can still get back to 10 anytime I want. But this is a pretty useful way for me to write 10. So this is really going to be 9 and 7/7 minus 5 and 2/7. Now, because I borrowed, I took one of my wholes and I gave it into fractional pieces. Now I can do my math here. 7 minus 2 is 5. So that's 5/7 left. 7/7 minus 2/7 is 5/7. And 9 minus 5 is 4. So 4 and 5/7. Now let's review. Dividing, this is A here, dividing 5 and 9/10 by 2 is equivalent to multiplying 5 and 9/10 by what number? Multiplying by 1/2 is the reciprocal of 2. B. Find 4 and 5/8 of 3. Of means multiplication. So basically they're saying multiply 4 and 5/8 times 3. So whenever we want to multiply involving mixed numbers, we have to turn them into improper fractions first. So 4 and 5/8, 4 times 8 is 32, and 5 is 37/8 times 3 could be written as 3 over 1. Now I can multiply straight across, and I don't see on my diagonals anything like, so I'm going to go straight across. 37 times 3 is 30 times 3 is 90, and 7 times 3 is 21. So that's 111 over 8. Now, I could leave it like this, but because my original information was given to me in mixed numbers, it's better for me to go from improper fraction to mixed number. So I'll divide 8 into 111. It goes into 11 once. With 3 left over, bring down your 1. Goes into 31. Only 3 times, because 3/8 is 24, with 7/8 remaining. So both of these are good, but this is probably the preferred since we started with mixed numbers. All right, let's have a look at C. Is it necessary to borrow when subtracting 1 and 3/10 from 3 and 9/10? No. Order matters, right? Because we're subtracting this from that. So it's actually being taken away from that. The from is always what starts it, and it's subtracting this goes in the back. So in this case, no, we don't need to borrow. D. To subtract 11 and 20/30 from 15 and 3/30, is it necessary to rewrite 15 and 3/30 as what mixed number? Well, because you can't subtract 20 from 3, we have to borrow. And so this will be 14, and then I'll give 30/30 to my 3/30. So really what this would look like is 14 and 33/30 if I put these together, minus 11 and 20/30. Because you can see here, this is an improper fraction, right? So it's really greater than 1. And so if I were to take out the 30/30, I could add a whole 1 to my 14 and bump it up to 15. And so it's an equivalent mixed number. And it's what I need to do in order to do my subtraction here. So hopefully that was clear and that helps you with this section. And if you have any questions, let me know. I'll see you in the next section.